Before moving on to a description of the final project for this section, I first wanted to just take a quick pit stop and talk about where to go from here to continue your education on differential privacy. So the first and most resounding recommendation that I can give right now is to read The Algorithmic Foundations of Differential Privacy by Cynthia Dwork and Aaron Roth. This is the comprehensive book on the subject. I hope that this video series is actually giving you a really great foundation and intuition and code examples to be able to work with this book. So the pros are, I mean, it's the definitive work, and it's free online. So you can actually so actually, I guess Aaron Roth is actually hosting it for free that people can download. It has sort of the full field. I think it was written in 2013. So it has lots of very modern mechanisms, some great stories and great intuitions. I think the most challenging part of it is that it really, once you get into it, it delves pretty deeply into the math and the formal proofs. And so if it might be more challenging or more dense if you're not used to working with this kind of set notation. However, it is truly the definitive work on the subject, the comprehensive work. You know, if you're going to teach a course in differential privacy, this is the textbook that you want to use. And so I highly recommend checking this out. Secondarily, you should certainly check out this paper called The Deep Learning with Differential Privacy. It had some really, really great concepts that I think are going to be quite influential, or already are quite influential and will continue to be so within the field of deep learning. As far as topics that you should learn next, so if this course was longer, we would have jumped into, say, the exponential mechanism. We would have jumped into Moments Accountant, which is actually talked about in this paper, as well as differentially private stochastic gradient descent. And I also am confident that before too long, these algorithms will be present in sort of the existing toolkits for differential privacy. They should be relatively easy to use, and so at the very least you want to become familiar with the interfaces and the APIs of what these algorithms sort of signify and mean. And then finally, there's a bit of advice. So if you're used to doing deep learning, you're probably used to sort of jumping in with both feet first, and then maybe asking questions later, right? And I know that in my own pursuits of deep learning, I've been very aggressive in sort of getting my hands dirty with these techniques and like really going for it. However, when doing differential privacy, there are sometimes small nuanced things that can actually cause you negative exposure, right? People can actually get hurt if private information gets leaked because something wasn't implemented correctly. And this is different from, I think, kind of the culture that is most popular in sort of the AI and deep learning communities where if you train a model and it gets like 99% accuracy instead of 100% accuracy, 9 times out of 10, it's not going to be that big of a deal. And with privacy, it's a bit more like cryptography, where like if you're off by just a little bit, sometimes that can actually be sort of a catastrophic mistake that someone can exploit to then steal lots of information. And so for your actual deployments, the first thing is I would recommend to stick with public frameworks that are sort of open source, actively being developed on, that lots of people have their eyes on, because this is an early field. There's still sort of proofs that come out that push against different techniques. So for example, there's been a paper recently published talking about how for Laplacian distributions, so you remember we were using Laplacian distributions for a lot in this course, that if you use a Laplace generating function that isn't implemented in quite the right way, there's actually an exploit to be able to leak more information based on the fact that you're using floating point numbers, okay? And so like even if you implemented the algorithm correctly as described in this course, as described in Cynthia Dwork's books, there can still be little gotchas in the actual computer science implementation of these things, just like there can be little gotchas and sort of workarounds in sort of cryptography, right? So writing cryptography libraries can be very challenging. So all that is to say, if you actually are interested in implementing this within your own organization, I highly recommend sticking with published code that people are vetting, that people are attacking, that people are doing DevOps on. Because if you try to roll the whole thing from scratch yourself, it's going to be more challenging, and it's going to be more likely that you'll introduce vulnerabilities that you might not know about. Secondarily, on a bit more of a more positive note, join the differential privacy community. So it's a small but quickly growing community of very interesting folks at the intersection of, so some folks come from a machine learning background, some folks come from a statistics background, some folks come from a cryptography background. It's a really vibrant community, and I've been very pleasantly maybe not surprised, but like I deeply enjoy being around people in this community. They typically have a really strong social bent. Like they really are interested in actually making the world a better place, and I really have enjoyed being a part of this community. I highly recommend doing so yourself. So you can do this by going to conferences, going to workshops, obviously join Open Minds Slack, which we'll talk about I think a little bit in the next lesson. There's lots of other people who are interested in differential privacy, but it's really a vibrant group and I highly recommend it. And third, don't get too ahead of yourself on deployment. So again, this is a bit more like the first point. You've gotten a solid introduction to the concept of differential privacy in this course, but this is by no means a comprehensive course. This is not enough to do a production deployment at the moment. However, this is, I think, a great introduction to the field of differential privacy, and ultimately will lead you to the skill sets necessary for production deployments of these algorithms. So the other thing to do is to keep track of state-of-the-art research. So there's still research being published. Many of these algorithms are still debated, right? So people still try to make counterpoints. Oh, maybe this isn't perfectly privacy preserving. So stay up to date on the literature, because it's a fast-paced field. There's new mechanisms coming out all the time. There's new forms of differential privacy, new definitions of differential privacy coming out all the time, and it's really exciting field to be in. But just be very, very mindful when you're interested in doing this in production, sort of in the real world, of just how new this field is, how quickly it's changing, and how new the code bases are as well that are actually implementing these algorithms. All right, enough on that. Let's jump into the final project.